Okay, here we have another problem that is very similar to the one we just did, where we were having to multiply by the conjugate in order to get rid of this I here in the denominator. It's very similar to rationalizing a denominator. Okay, I wanted to look at this one specifically because it sometimes it's easy to see if we had had a 5 plus in here, then we would know that the conjugate would be 5 minus 2i. That we don't seem to have too much trouble with. But whenever there's no whole number here, for some reason we have a little bit more difficulty seeing that complex number. Remember when we were writing, the conjugate, when we were writing the conjugates, remember I said that it is only the imaginary part that changes sign, not the real part. Well, this one we don't even have a real part. So the complex conjugate would be just negative 2i. So that's what we have to multiply top and bottom by, so that we're just multiplying by that 1. Okay, so by doing that, now I'm going to have to distribute, and I think it'd be easier to look at distributing the negative 2i, kind of going backwards there. So 3 times negative 2i would be negative 6i, and a positive 4i times negative 2i would be a negative 8i squared. All over 2i times negative 2i would be negative 4i squared. Okay, now we can do some simplifying here and some cleaning up, because I squared is always a negative 1, and negative 8 times negative 1, this becomes really a positive 8. So if I were to rewrite that numerator, I would write it as the real number part first, the 8, and then the minus 6i, so that it's in the perfect order. Now for the denominator. This I squared is a negative 1, so negative 4 times negative 1 is really a positive 4. Now we still need to clean this up, because we don't want to leave it as a single fraction. We need to show a real number part and an imaginary part. So I'm going to separate this out into the two fractions that it truly is. So that would be 8 over 4 minus 6 over 4i. And now we can simplify each step. So 8 over 4 would simplify to 2, minus, for the 6 over 4, they have a common 2 that we can factor and cancel, or divide out, however you want to look at it. So 6 divided by 2 would be 3, and 4 divided by 2 would be 2i. So this is the simplified version of our original problem.